Sir, we will start, sir. So total 24 has joined.
Thanks, thanks, Raghu. So I'll just
Yeah, very good afternoon
start.
to all of you. Welcome for this third session of the day one. So first off, will take by Vinayak Pishik. So the next 1 hour I will take. So we are going to cover the method of economic evaluation most probably in this session.
Hi, can you hear me?
Yes, sir. Yes.
All right, perfect. Hope you all have had a good lunch, and it's dinner time here. So no, but all good. So hopefully all excited for the next session. So the purpose of the next session is the way I'm going to approach it is put forth. Let me share my screen first. Is I'm going to share
Yes, sir.
an
Visible.
example. Yeah, is it? Can you see it? Yeah.
Yes, sir. Yes.
So I'm going to give an example, right? Like here we'll do a cost benefit analysis of a particular project which we have made up. And what I want us to do, like as we go through it, it's a made up example, but there are going to be steps which are right, but there are assumptions here which we want to, which I think as a group we should discuss. Is it right? Is it wrong? Um, and what might happen? Okay, so that is the intention. So uh, stop me at any point of time during the discussion, and feel free to put in put in notes on the um, on the chat. And instead of me kind of flipping back and forth, if there's a just open up your mic and speak, please, if that's okay. So here's the thing. Here's the project I made up, so that we can go through the steps. We can go through the steps, and what I'm going to do is I'm going to share a spreadsheet as well, and I'll go through the spreadsheet. So there's a 100-kilometer corridor, and it is a two lane highway, which becomes a 4 lane. So that means initially there was 1 lane in each direction. Now there are 2 lanes in each direction. The capex. So what a capex is it is the initial cost of building it. The cost to build this is 2,000 crores, and it takes 2 years to build this. So the first year it is going to be 60%. The next year it's going to be 40%. All right. So that is the first result. The operations and maintenance is rupees 50 crores per year. So that means every year making sure that it is the road is cleaned. There is the pavement is of the right condition, is rupees 50 crores a year. Any thoughts about this particular assumption, first of all? Any thoughts? See if I'm okay. Yeah. All right. Nothing. No thoughts so far. What do you think should happen? What do you think should happen to the operations and maintenance as the years go by? Will it remain? The first year, would you be spending 50 crores a year in operate when it's a new road? Not really. I think if it's a new road, it might be maybe 3 crores just to kind of make sure that if there's an accident, you're repairing it and all. But generally, what happens is your operation and maintenance cost goes up as the years increase, right? So, like I said, it is important that's what I'm hoping to for you all to be thinking about is um, are all of these assumptions right? So this is an assumption right here. let's assume that it is 50 crores per year, but in reality, it's usually going up. Okay. Now, the traffic AADT. So the average annual daily traffic is approximately 20,000 vehicles per day. Okay. With the 40% cars, 40% trucks, 20% buses, at a growth of 5% per year. This is fine. This is what generally comes from the demand forecast. So based on the demand forecast annually, this is what you develop. Now, there is a before and after speeds, right? So before, the cars were traveling at 45 kilometers an hour. Now it's moved to 70 kilometers an hour. It used to be 30. Now it's moved to 55. Um, um, it used to be 35. It's moved to 60 kilometers an hour. So basically, the speeds have increased. Now, the question is, can we assume that this is actually going to be true for the next 20 years? Not really, right? Usually what happens is, um, in the first 4 or 5 years, your speeds are going to be the increase, the benefits you'll observe are what you observe. But then what happens is the number of vehicles will, as the number of vehicles start increasing, right, the speeds will also start reducing. So we need to be able to develop a model for that as well. Like what is going to be the speed every year. But for in this case, let us assume that this is what it is. Any questions, any thoughts so far? I mean, trying to. No questions so far. Okay. All right. The next thing. Oh, right. So we have finished this. Then the value of time. So the value of time is rupees 150 per hour. Trucks is 1,200 rupees per hour, and the buses is rupees 500 per hour. The vehicle operations costs are rupees 2 per vehicle kilometer, 0.5 per vehicle kilometer, and rupees 1 per vehicle kilometer. Okay. Then you have safety and emissions. So what is the improvement? And we're going to actually spend a lecture on trying to go through how do we evaluate the economics of crashes. We'll talk about that as well. Crash reduction benefits. Emissions is straightforward. It's you basically look at the health benefits of that, but crashes are a bit more nuanced. So here we have just found, we have based on a previous study, it has been found that it's going to be rupees 20 crores per year. And the emissions reduction is rupees 10 crores per year. And the discounting rate and life is 10%, 20-year evaluation period with a opening at year 2. All right, so this is the underlying case. Now, I have prepared an Excel sheet. All right, and we will go through each one, and I have definitely made some mistakes, and we'll go through, and it'll be great to figure out if any of you have picked up on those mistakes. All right. Okay. So a couple of hints I'll give you where the mistakes are. First of all, remember that the traffic is AADT. The VOC savings are vehicle kilometers. All right. So I'm going to open up the Excel sheet. So this is basically the net benefit. We'll work through that. So as discussed, capex is 2,000 crores. OPEX is 50 crores per year. ADT is 20,000 vehicles, which is basically average annual daily traffic. Cars is 40%, trucks is 40%, buses is 20%. The growth of these is 5%, right? The car speed is 45, it becomes 70. Truck speed is 30, it becomes 55. Bus speed is 35, it becomes 60. And then we have value of time. So value of time savings is basically telling you that if I save 1 hour, it is worth 150 rupees of benefits we have realized. If we have uh, saved 1 hour on a truck, it's 1,200 rupees. And for a bus, it is 500 rupees. All right. Again, this is the value of uh, value of op operations. So VOC savings per for a car. So what it's saying is basically what will be the what VOC captures is the operational cost. So if the roads are better, there'll be less fuel. There'll be more fuel savings. There'll be less wear and tear on the car. So how much is that worth? That is 50, 50 paise per kilometer. For truck, it is 2 rupees per kilometer. For buses, it's 1 rupee per kilometer. And the crash reduction. So all that. Opening in year 2. So year 1, 60%. Year 2, 40%. So let's go through this. Any questions so far? Is it making sense?
Yes, sir.
It's making sense, yeah.
So
far,
when you're
yeah.
looking for the value of the time or even the vehicle operation cost, so generally it is expected that it may changes respective to the region, like the city to city value of the time specifically.
Yes, correct.
But when the codal provisions are giving, like the IRC SP30, even for the 2019, they have given a maybe like kind of standardized values of the value of the time. The vehicle operating cost also, they have taken the different examples, and even for that, so they have given the different standards of the vehicle operating cost. So in such cases, when you are considering a project which is originating from the X point to the Y point, so which is stated from the state of like Tamil Nadu to the maybe West Bengal, suppose. So then obviously the value of the time respective to these two regions will be different. How this point can be addressed actually when you're doing this analysis?
Okay, so that's a great point. So when we are doing value of time, right? So the value of time is basically associated to a certain household. So when we do the value of time analysis, it is basically at a fundamental economic level. The value of time is basically associated to the loss of opportunity cost. It's the opportunity cost of traveling. So if I was not traveling and was able to do the same work in my home, or what would be that saving? That is the question. Okay, so usually when we are looking at value of time, we look at value of time based on the origin trip, if that makes sense.
Yes, sir. Yes.
Okay, so when somebody is going from let's say Uttar Pradesh to West Bengal, it is based on the origin household. Now, what also happens is, to your point, um, there is heterogeneity in the value of time within a region. So going back to Manish's example of Bombay, the value of time in Thane is very different to that in Navi Mumbai, very different to that in Ghatkopar, very different to in Marine Drive. So we then do heterogeneity of value of time based on these different groups, or we just take an average value and do an analysis saying that, look, we understand that there's heterogeneity, but we'll take this one value, and this is an assumption which we all agree to for the purposes of our prioritization. Now, once we have all agreed to that, then that's basically what the results will say. So a lot of these choices around these parameters are a matter of agreement to all the stakeholders. And this is where it is it makes a difference. It makes a difference, and it is related to the policy. So for instance, if I had taken an average value of the value of time for the whole city, I won't be able to do an analysis of equity or fairness. So if I'm getting benefits from a value of travel time savings perspective, then I might be, and the the VOT is got a heavy tail, like the distribution where there are a small number of people, but with extremely high value of time because they're very, very wealthy. You have the Reliance guys and all of that there. So they're very, very wealthy. So, but they have moved the average value of time to somewhere to the right, but it's not equal to the mode. And so you are not giving benefits to the people who might really need it, who might be of the lower economic classes. And that is where that choice really makes a difference. But once, like, say, the IRC specifies, so here that is an issue as well everywhere. So usually there's a government circular or a government uh, mandate that is provided, and we generally for projects, if they're saying that that's what it is, then that's what we use. But when we are trying to do analysis based on equity or fairness or something like that, then we have to provide a documentation saying that we are going to be not relying on these numbers because this does not capture the uh, performance indicators which we care about. I don't know if I made sense,
Yes, sir.
Raghu.
I got it. Yes.
Yeah,
Yeah,
perfect.
it makes sense.
So that's a great point. So there's and there's a lot of work around that. So you can actually, from a modeling standpoint, you can look at different values of time. Now, so let's look at each year and see what's really happening, right? So I should have. So the first year, the cost is, because only 60% of it is taken care of, the cost is 1,200. So 60% of 2,000 crores is 1,200 crores. The next year, it is 800 crores. Okay, the cost. Now, the main thing to remember is we are also looking at it from a net present value perspective, right? So there is a 10% discount rate. So the first year is 1,200, but the second year will be 1,200, 800 divided by 1 plus 10%, that's 1.1 raised to power 1. So it's what you're doing is the $1, which is, so so $1 today means more than $1 tomorrow. But how much more? And that's what the discount rate is capturing. It basically is a factor you divide by. All right. So this part, so when I look at this discount rate of 10% here, what I do is, if I look at 100 rupees today, and I'm telling you that I'll give you 100 rupees in 2 years, right? So in 2 years, the 100 rupees for me would be worth 100 divided by 1.1 raised to power 2, 1.1 square. In 3 years, it will be 100 divided by 1.1 cube, and so on and so forth. Does that make sense? That's an important concept of discounting.
Sir, can you please repeat it?
Yeah. So what I'll do is I'll write it out. So I'll write it out here. So let's say there's $100 today. Okay. Um, now, and I'll tell you that I want to give you. So let me give you a choice. Let me give you guys a choice. If I give you $100 today, or $100 in 1 year, which one will you choose?
One day.
Today, right? You'll get it today only, because what is the point of waiting? Now let me make this 105 rupees, $105, or let me make it rupees. 105 rupees in 1 year. which one will you take? Will you take 100 rupees today or 105 rupees in 1 year?
100 rupees today.
Today. So there is going to be some number which you will say, maybe you will not even take 110, correct?
Yes.
Will you take 110?
No.
It doesn't, maybe not.
Yes, sir.
150. Let's make it a little bit more interesting. Will
No.
you take 150 in 1 year?
No.
No. How about 200?
No.
No. How much will you take in 1 year?
1000.
1000. Wow. Okay. So what is your discounting rate? Let's try to calculate that. So it's basically 100 is equal to 1000 divided by 1 plus x by 100 raised to power the amount of time. So the time is 1 year, so that will be this. So you solve for x. What will be x? So x will be roughly, it'll have to be 10, right? So it'll be 900. So basically x is equal to, this implies x is equal to 900. So you will need a 900%. So your discounting rate is 900% on 100 rupees. Am I making sense? This is what a discount rate means. So the 100 rupees tomorrow is not worth 100 rupees today. 100 rupees tomorrow would mean probably 50 rupees for you today.
Yes, sir. Got it.
Got it? So this is how you do discounting. So now so what I am telling you right now is based on interest rates, and there are a lot of factors that affect this discounting rate which we use. It depends on interest rates, it depends on bond rates, it depends on how much, it depends on fiscal and monetary policies of a country. But what you're doing is basically you say that in 10 years, or let's say in 10 years, how much will this 100 rupees mean? So that'll be 1 plus 10 by 100, because I've got a 10 raised to power 10. So that is equal to 100 divided by 1.1 raised to power 10. That will be what it will be equal to. And I can do a quick analysis. Get my calculator out. It's basically equal to 38 rupees roughly. That's basically what it's saying. So that is what discounting is. Clear? So what I'm saying, so this is 1200, 1200. So 800 is 800 divided by 1.1. Now, after the second year, the operation and maintenance cost remains the same, 50 crores per year. All right. So what I do is 50 divided by 1.1 raised to power 2. 50. So you'll see all these, these costs, these costs are reducing at net present value. And after 20 years, it only becomes 7.4 crores. So even though you know that you're going to be doing 50, it is worth 7.4 crores because you're discounting it. All right. That's number one. Benefits. Okay, so that's the cost column. And then that's the net present value for the cost. Clear? Any questions?
Not from my side.
Nothing. Okay, good. Then next, benefits. All right, this is where things become a bit interesting, complicated, and I've made errors. All right, so let us see if you're able to pick it up. So what are the benefits? So let's talk about the first benefit. The first benefit is travel time saving. Travel time saving is what? We have a length of 100 kilometers, right? So now today it takes 100 divided by 45. That is the number of hours it takes. But I would, if I'm able to travel at 70 kilometers per hour, it would be 100 divided by 70. So it will take us less time. So the difference in these two, 100 divided by 45 minus 100 divided by 70, right? That's what I've done. So if I look at this, if you look at 100 divided by 45 minus 100 divided by 70 is equal to the travel time savings of the car. That is around 0.8 hours. That's around 48 minutes, or let's say 47 minutes. Closer to 48 minutes, but that is what I'm saving. For buses, it is close to 1.2 hours. So that is 1 hour and 12 minutes, roughly. Okay, so that's what I've done. I've just taken 100 divided by 35 minus 100 divided by 60. That's the bus. Then I've taken the truck. Truck is again roughly around 1.5. So that is 1 hour 30 minutes. And that is 1 divided by 30 minus 100 divided by 30 minus 100 divided by 50. So that's the amount of hours saved. All right. Now we know the total number of cars.
Yes.
The ADT of cars is, oh, so one thing I forgot also. We also know that it is increasing by 5%. So this is 1.05. You multiply that 1.05. So that's basically what's happening. So every year it's increasing by 5%. So it starts increasing. So you can see that the volumes are increasing. But the travel time savings are remaining the same, even though the volumes have increased. It's an assumption here, but usually what will happen is that the travel time savings will also reduce. So it'll stay constant, and then because there's congestion, it'll start reducing the travel time savings. That's usually what happens. So to get the economics of this, to get the economic value of the travel time savings, what I'm going to do is I'm going to multiply the total cars with the travel time savings of the cars, plus the buses multiplied by the travel time savings of the buses, plus the trucks, number of trucks multiplied by the travel time savings of the trucks. And that's what I've done here. So if I look at this part, this piece is doing that. Can you tell me if there's anything wrong in this first? What is AEDT? It is telling you the average annual daily traffic. So there is roughly around 20,000 vehicles per day on average. Correct? So what have I missed? So I'm only calculating the benefits per day, not over the year, right? So far. So I'm telling you that so many cars are coming in a day, and that's the travel time savings. But there are 365 days. Have I lost you all, or am I making sense, or what's happening?
Yes.
All right. So this is one of the most common mistakes that are made. I remember in my undergrad that I lost 10 points for this, but it is such a common mistake people make that So you really need to multiply that with 365.
Yeah.
Yeah.
So, sorry, sir, I interrupt you.
Okay.
This value that you are getting is ADT, right? That we have multiplied
ADT, average annual
after
daily traffic.
after multiplying 365, it is converted to ADT, right?
ADT. Yeah. So it's not. It's so I'm getting the average annual T. So I'm getting the annual traffic then.
Okay.
Total annual traffic
Okay. For year.
per year. Yeah,
Okay.
at the moment I multiplied with 365.
3 PS. Got it.
So I'll have to. Sorry, just give me 1 second. I'll have to do this properly. It's not accepting. What has happened? N4. Sorry, let me. So I have to multiply this with 365. End of that. Okay. Sorry, just give me 1 second. All right. So this is what the this is what is the. So I'll just go here. So this is basically telling you the travel time savings. Then the next piece is associated to the $B15. It's associated to the operating cost, and that is very simple. Every car, multiply that with the multiply that with the this number. But it is, remember that this is INR per kilometer. So I have to actually multiply this with 100. All right. I have to multiply this whole thing with the length, as well as multiply this with 365 as well.
Sorry, before you multiplying that, before we multiply to the length, after that we multiply through cost value, right?
Correct.
Got it.
So if we have to multiply that with the length, and we need to multiply again with 365 because that's the number of, because we're multiplying it with ADT still. Correct?
Yes, sir. Yes.
So that's what we're doing. We'll do that here, Command V. All right. Now we have updated that. That's good. Then the next thing. We also know that the crash reduction saving is 20 crores per year, actually. This is per year. And this is 10 crores per year. So what we do is we just multiply that. So what we'll do is this is 20 crores. So let's take this. So this is 20 crores. So this I've just multiplied it with crores, and that is 10 crores. And then I just divide the whole thing by 1 crores to make the whole value in crores. So that is around. So this is not cost. This is benefit. Is around 1,116 crores is the benefit, which we observe in the first year itself. So the net present value is around 1,000 crores. in the third year, and it starts reducing. Okay, so this is pretty much how we end up doing this analysis. So what you can then do is then look at the benefit to minus cost. So it's telling you that first 2 years is going to be negative, and then it ends up becoming positive, goes high, and then it starts reducing down. Any questions? So this is what I've done is I've given you a very complicated model, complicated question, but have kind of gone through some fundamental concepts. The first concept is the concept of discount rate. Okay. The second concept is that of how do you calculate the economic benefits based on value of time. The third concept is what is the economic benefits based on savings, operational cost savings. Then how do you then add that all up across crash reduction, emission reduction, and then do a net benefit. So when you're doing this over a 20-year period, you can actually calculate the cost benefit. Now, if I take the ratio of these two, I'm getting a 5.23 cost benefit ratio.
Got it, sir.
So so I have changed a lot of the numbers from the previous slides. So don't use that, use the solutions there. So I just wanted to go through this. I'll share this share this with you on in the chat, so you can actually go through this. Any questions so far? This is basically the fundamental starting point of any cost benefit analysis piece. Any questions? I don't know if I'm able to share attachments. Let me see.
Sir,
Yes, Rahul.
sir, I request you, sir, can you please share this Excel sheet? Actually,
I
it is
am
getting
trying to do that.
complicated.
Yeah,
Actually, it
I'm
is
trying
getting
to.
complicated.
Yeah, I'm just trying to do that and go through this. Go through this. Go through the slides. Go through the Excel sheet, and we can talk about it. We have the next 4 days as well. We can talk about it later today and or tomorrow morning as well. And we can go through it again. But I'm trying to share this. I'll email it to you, Raghu, if it's okay, and then we can
Okay,
share
sir.
it. Okay.
Okay, sir. Sure. I will share with them.
Perfect. I'll do that. I know that there are several concepts I've put together, but I wanted to just go through it step by step and walk through that. Any questions?
Sir, in case we are considering for annually, can we consider it for monthly basis? So what is the change in case?
Good. You can have a monthly thing as well. What will be the change? The change might be the discount rate would change a bit, because the monthly discount rate you need to if it's a 10% annualized discount rate, what does it mean per month, right? So you need to kind of come to that value, right? And what you will then get is at a monthly level, month level analysis. So sometimes it really matters, particularly for I'll give you an example for concessionaires. For concessionaires who have borrowed money from banks, or who have borrowed money from from big funds. They're paying huge interest rates, probably 7 to 8%, or even more sometimes, even like 12%, to their investors. So it really matters every month. When can they break even? So that's when it's really, really useful. But when you're doing a DPR, usually you don't care. When I say you don't care, you're trying to look at you'll only look at the last cost benefit ratio. Manish.
Yes, sir.
And if you have 10 projects, you'll kind of then, based on the cost benefit ratio, if the benefit to cost ratio is whichever has the highest one comes first, then second, then third, then fourth.
Yeah. Prioritize.
Yep.
Got it.
Any other questions? Any thoughts?
Sir, regarding this lecture, I want to understand one concept, sir. That is
Yes.
of maximum benefit, sir. What is it term, sir? Maximum benefit.
Maximum benefit. It can be in various contexts. So it really, you always have to say maximum benefit with respect to what. So for instance, somebody might ask you, all right, this is your benefits and costs, but from where are you deriving your maximum benefits? Is it from the travel time saving? Is it from the operational costs? Or is it from the, so that is one aspect of it. So what you can do is you can split it up and look at the percentage. So let's go here. I'm not sharing my screen. Give me 1 second. So it can be, it really matters. So the question is very, how should I put it? Can be interpreted in different ways. So I'll, this one. So you know how there are these 1, 2, 3, and 4 parts to the benefit. Travel time savings, operational cost, safety, and emissions. Which one is providing you the maximum benefit? That could be one question. The second question could be, which year are you observing the maximum benefit? It's probably the second year, right? So that could be another question. Which year are you? So the question could mean a lot of stuff. Happy to take. Does that answer your question? It needs to, there has to be something, for me, at least in my interpretation, there has to be an additional adjective to, or an additional qualifier to it. An additional qualifier in terms of maximum benefit from what, in what context. Does that make sense, Rahul?
Yes, sir. Yes, sir.
Yeah.
Thank you, sir.
So whenever somebody says, what is the maximum benefit, ask them with respect to what, in terms, and you can give them options so that, sometimes the best way. So I'll give you my own experience of working in this space of transport economics. When somebody asks a question, asking a question back is usually people get the person who's asking the question, who's generally your client, they get upset because they're like, oh, you're asking a question to a question. So usually what I do is I provide options to my interpretation of the answer question. So like I said, when somebody said maximum benefit, okay, maximum benefit could be this, maximum benefit could be this. I hope that answers your question.
Yes, sir. Thank you, sir.
So that is a very important strategy as well. When having discussions around this, because it's a very transport economics or any kind of appraisal, any infrastructure appraisal or anything, it is based on so many assumptions that the whole idea of this is to actually get everybody to agree on the similar assumptions and say that, look, yes, we agree that that could be an assumption, but it has this problem, but we can take this into account. We take it into account, but it's not really affecting the prioritization. So sometimes it is problematic to get into uh, I would call what is right. When you're making assumptions, there's nothing which is right. It's all based on assumptions, right? Like, this all based on certain level of agreement on assumptions. So we have to kind of create narratives and come to a and provide evidence. When I say create narratives, it's not just making up stories, but create narratives based on evidence to convince the stakeholders that this is an appropriate analysis.
Understood, sir.
Yeah,
Thank you, sir.
thank you. And sometimes the best way, like for me, it has always kind of uh, uh, Raghu has watched this happen a few times. Is if there's an IRC guideline, just say that, okay, this is what has been agreed upon based on the IRC guideline. That's why we are using this, or this is what has been observed in the literature. That's why we are doing this. Do you have an alternative? Then you have to ask them, do you have an alternative? We can take your alternative and put it into the model. But that is a fundamental thing about transport economics or transport appraisal or economic analysis as well. In fact, a very one of my colleagues, he was involved in a lawsuit. So a lot of these are also, like, a lot of these appraisals are associated to lawsuits and legal lawsuits, where if something has gone wrong, how much do you need to pay out the the people who have been affected, right? So, for instance, one example has been around smoking, right? Because of certain advertisements, it was improperly advertised, and because of that, there have been uh, health effects. So, how much should it cost? And when it gets into legal, every time that every assumption is thrown apart, and you have to kind of defend those assumptions and say that this is what it is based. Similarly, for Exxon Valdez, there was a oil spill. So these numbers they happen through a lot of discussion, and people come to an agreement on a certain. But you have to kind of carefully think through that this is an assumption. This is what is based on certain uh, evidence, or if there is no evidence, then you have to go and collect data on value of time, on discount rates. So, like the experiment I did, where we found that for $100, there's a 900% discount rate in a year. So, so that, and the other assumption we have made is that the discount rate is constant, but the discount rate could also be changing over the years. Yeah. Interesting. Any other questions? I wanted to actually talk about one thing about discount rate. So even I think going back, it just occurred to me to your question around years versus months, right? So let's take this example. I took my unit as years, right? So 1,000 years. So sorry, 1,000. So what is your discount rate at a year on a year level? But if I make it months, right? This becomes 100 is equal to 1,000 divided by 1 plus x by 100 raised to power 12. We can actually calculate this. So it's the 12th root of 10. It'll be a different number, which you'll get. The monthly discount rate. I'll leave it up to you guys to calculate. I'm using my phone, so my eyes are not able to get there. Any questions so far? A lot of fun. Good questions. Any other thoughts, questions?
Sir, I have one question, sir.
Yes. Ask now.
Sir, while doing crash modeling,
Crash. Can you
yes,
explain that?
yes, sir. Before the sir, we have to use different resource allocation methods. Before that, we develop some countermeasures. That's why we develop some crash modeling.
Oh, crash modification factors. So you're talking about
Yes,
crash.
yes,
Yes.
yeah.
I'll be doing an entire lecture on that. Don't worry.
Okay,
But tell me now. Tell your question, so I can accordingly frame
sir.
the.
How can we decide countermeasures in the area of the hilly regions? Actually, it is totally curved. So, can we decide it on the basis of sections or intersections or both, sir?
So in crash modification factors, one of the things is you have to use you use uniform sections, right? You use uniform sections. Now those uniform sections can be decided by three ways. One, in hilly sections, it is based on a particular section having a certain curvature, right? Then a second section could be based on transition of curvature. So where you're moving from yeah, you have a positive radius to a negative radius. So you're so that transition is a second section. And those transition points have different properties, right? You're trying to move from a radius of plus 10 to minus 5. So you can either go heavy, you can transition in different ways. So you use that as your uniform section. The next one is a next. So that is one piece, that's how I would actually uh, set it up, but it's a research question in itself. How do you define different uh, different sections, uniform sections? So your point is around how do you define uniform sections in a hilly region where things are changing every 100 meters. So it's every 100 meters, it has to be defined by its properties.
Okay, sir.
Does that make sense? And then you can change it. I remember very clearly, this was 2008, almost 10 years back, or 10, no, 12 years back, 12, 14 years back. No, not even 14, 17 years back. 2008, we were doing crash modification factors of intersections, at intersections. One of the questions that was coming up with intersections was, when an accident happens, how do we define it, whether it's due to an intersection or not? Right? Because at an intersection, you can be 100 meters away, 200 meters away, 500 meters away, a kilometer away. Now, 1 kilometer away is, you can pretty much say that it is not influenced. 500 meters also, you can say not. But between 200 or even 150 to, what is it? So what usually people do is they do sensitivity analysis based on that. When is it that things are not changing? So things keep, the model fit improves, and then after that it doesn't matter, or things start improving, decreasing. the model fit starts decreasing. So that is another way of actually doing sensitivity analysis. So when you're not sure about how you need to be developing your crash modification factors based on you, or how to define your assumptions, doing sensitivity analysis is an important way of coming to a solution.
Yes, sir. Yes, sir.
Cool. Sounds good. Any other questions, thoughts? So key takeaways: economic benefit. First of all, discounting. How do you actually account for discounting in your net present value? That's number one concept. Benefits can be measured based on travel time savings, operational cost savings, safety, emissions, and there might be others as well, but these are the usual ones, usual culprits to this game. If no more questions, I can hand it over to Raghu, but happy to take more questions. This has been fun.
Sir, one
Yes,
request:
Mani.
travel time, operating cost, safety, and last one,
Emissions.
emission.
Emissions.
Okay. Okay.
At least that's what I considered. There might be somebody else who will be like, but because of these roads, there is going to be more agglomeration. There's going to be more um, logistics cost. There's going to be reduction in logistics costs, right? So you have to then account for logistics costs and other aspects as well. But yeah, but at least in this case, logistics costs can be also based on inventory, like the and I'll go through an example for that. I'll go through an example for that.
Yes. Yeah.
All right.
Thank you, sir. Thank you so much.
Thank you. Thanks, Raghu. I'll stick around. I'll just listen to the next phase.
Sure, sir. So hopefully my screen is visible to everyone.
Yes, sir.
Yeah. So I'm straight away starting with the IRC SP30. So of course it is updated in 2019. So, but the example what I have taken in corresponding to the one project, that is respective to the numbers of the 2019. So that's the reason I have not updated the some of the numbers, because if you go back and look at the SP30 2009, so these numbers will be there respective to the assumptions specifically. I thought of giving before this actually introducing of the some method of economic evaluations. Most probably that session, maybe that half an hour session will be going to look at tomorrow morning session. So let's start straight away the discussion about the how the economic evaluation of the highway projects will be taken. So generally, if you look at, there are different types of the cost involved into the transportation. So the road user cost is one of the important component actually. So that is the cost of initial construction of the facility and cost of the periodic maintenance and the road user cost, what actually even Professor Vinayak has given just before this session. So then we have the vehicle operating cost, we have the accident cost, we have the travel time cost. So these costs generally to be estimated based on the different factors to be identified or to be factors to be considered. So when we are estimating a like specifically when you are talking about the vehicle operating cost, it is all about the conditions of the vehicles, the fuel cost of the vehicle, and the depreciations of the vehicles and the components involved into the vehicle. Like together, there are several factors involved into the estimations of the the vehicle operating cost. And apart from that, the speed corresponding to the given stretch or the selected roadway, that is another important component. So like if you see the vehicle, the VOC component alone, the fuel, lubricant, tires, spare parts, and the labor for the maintenance and the repairs and the depreciation all together put, so generally we'll estimate the vehicle operating cost. So then these elements influenced by the variety of the other factors even. So that is corresponding to the conditions of the road, what is the pavement width and what is the surface condition, whether it is the curve or like the non-curve sections, what is the vertical profile of the road sections. So like there are several other factors are also impacting on the VOC. So because the VOC generally get varies respective to the change of the alignment due to the horizontal or maybe like vertical. So because of the change of the alignment, maybe expected the change of the speed. So corresponding to the change of the speed. So there is a acceleration, deceleration parameter of the vehicle get changes, and respective to that, so there is a change of the vehicle operating cost can be expected. So then apart from that, so the vehicle factor also makes impact like the make and the age. The make is another important factor generally. So like if you see the older and older vehicles might be emitting more amount of the emissions, might be consuming of the more amount of the fuel. So then the speeds is not expected that effect actually. So that's the reason. So the vehicle make as well as the age, so having the different impact on the vehicle operating cost. Then apart from the traffic related factors like the speed and the volume of the traffic, so that may get changes respective to your VOC. Like if you have traveled along the highest traffic conditions to the lowest traffic conditions, and respective to that there is a change of the speed, so that might be impacting on your vehicle operating cost. So then the environmental like altitude, then the rainfall, climatic conditions, gradient, all these factors makes some impact on your vehicle operating cost. So this is the just example of the Mumbai Pune Expressway. So like if you see, we are going to discuss how the length of the stretch they have estimated the corresponding to the total estimated cost of the toll. So then if you see the category of the road comes under the expressway, generally if you see there is a kind of the type of the route, most probably that is also defined respect to the category of the road. So like the primary, secondary, tertiary roads, the primary including of the national highways and the expressways generally, and the secondary including of the your state highways generally the major district roads. So this length of the stretch they have taken as a 72.58, and the number of lanes are included as 4, and the width of the road is 7 into 2. Total the 7 in one direction and the 7 in opposite direction. And the surface type is the bituminous, and the road condition is good. Like we need to get all the kind of the details to understand to estimate this process. And the roughness, that is the 2000 mm per kilometer, and the average rain rise and fall of the 5. And the curvature, generally we need to understand what is the degree of the curvature and how many number of curves we have, and corresponding to the change of the curvature or like kind of number of curves, if it is increases, then the vehicle operating cost is increasing, then corresponding to that the total estimated cost respective to the selected stretch of the road is increases. So then we have the intersections, that is also very important. If you have more and more intersection, that may be increasing the vehicle operating cost even actually. So then according to the 72.58 and respective to the design speed, so maybe like the around 120 kilometers per hour, then the time of the travel, it is can be estimated 1 hour 20 minutes. So like these are the kind of present day of the traffic corresponding to the selected stretch of the time. So generally this traffic is estimated respective to the continuously 24 hours and the 7-day traffic volume corresponding to that. They also estimated what is the peak hour capacity of the selected stretch, like that is the 4300 pcus per hour in the major direction, and corresponding to the traffic growth rate of the 9%. So then the cars they observed as the 2720 buses 1119, like these are the kind of traffic of the different conditions of these respected day of the selected survey. So to calculate the yearly traffic volume in terms of the pieces per day, so with a 9% of growth rate, that is from the 2019 to 2038 they have taken. So then the 10% of this daily traffic is considered as the peak hour. So which is observed as, so what is the average daily traffic corresponding to that? What is the change of the hourly volume respective to the peak hours of the day and corresponding to the non-peak hours of the day? Then they have taken as the 10% of this daily traffic as the very like the highest peak hour, like the peak hour volume corresponding to the calculating of the distance related and time related congestion factor. And both these congestion factors are to be calculated for the rise and the fall condition as well as the roughness case. So that's the reason. So respect to these cases of the rise and fall, or like the respect to the roughness, we have the base cases of the congestion factors. So like the time based congestion factors, we have like the distance based congestion factors that need to be multiplied with respect to the given data, like the given selected the rise and fall, or like the roughness values. So what actually we are doing currently here? So then we are projecting the total volumes from the 2019 to the 2038, respected to the given hourly volume. So with that volume, so then we are considering as the peak hour traffic volume, that is the 10% that is the highest peak hour volume corresponding to the each and every year category. Like we have the car, bus, LCV, heavy commercial vehicle, multi-axle vehicles, two-wheelers corresponding to the year of 2019. So then entire volume of the year is converted into the vehicles, then the PCUs, then these PCUs we are considering as the 10% is the highest volume. That is the peak hour traffic volume, highest hourly volume. Even if you observe that actually the volume what we are expect to get in a peak hour of a day is more or less is closer to the 2458 case. So then volume by capacity ratios are derived. So we know the capacity of a road stretch of the 7 meter width, or like the 4 lane divided roadway. So then we know the capacity, then there, we know the volumes. Then we are estimating the volume by capacity ratios corresponding to the values. So any questions up to this, or any points to be discussed specifically? Okay. So then we are calculating the congestion factors, that is the distance related congestion factors and the time related congestion factors. So if you go through the like the SP30, the 2009, that is the economic evaluation of the highway power projects. So then we have the table corresponding to the volume by capacity ratios of the what we have the volume by capacity ratio 0.57. So corresponding to that, so we need to find out the of course, if you see there is a congestion factor related to the distance based congestion factors first. So there is a formula 1.038 plus 0.14 into volume by capacity. So then corresponding to the volume by capacity of the 0.57, so we need to understand that what is the factor we need to have. So this factor we generally have the 0.8 actually. So then we need to multiply with respect to 1.178 into the 0.8, then we get the 0.894. So what we are going to do with this 0.894, so we are going to multiply with respect to each case, then we are going to derive a actual the affected values respective to the congested case of the given or like the projected traffic of the given base traffic. So then these calculations we have again factors. So like the distance related or time related congestion factors are separately calculated generally, and we need to apply some kind of correction factor. So then that can be affected with respect to, so whenever the value is less than 1, it may be considered as the 1. So if it is more than 1, so we have the correction factors respective to that actually. So like we have the this is the correction, so the distance based related congestion factor corrected values respective to the distance based correction factors, like whatever we have estimated like 1.147, so like 0.894, which is less than 1, so we are going to consider as the 1. So like that we are going to do corresponding to each case of the car, bus, the LCV, and respective to the each year. What it actually stating that, so we have the different flow of conditions of the vehicles of a given year or a given time period, and it is indicating that okay, there is a vehicle is passing, respective to that vehicle, so how many number of vehicles are actually accommodated, or like the adjacent the that vehicle is closing. So then what is the amount of the congestion is creating respective to this vehicle to the other vehicles. So that is the meaning of these congestion factors, what actually they have derived it. So if the vehicles are surrounded by more number of vehicles, which is indicating that there is more congestion respective to the occupancy of the vehicles to the one vehicle to the other vehicle. The same way we have the time related congestion factors, like this is the formula we have. So generally the VC, that is the time related congestion factor, which is derived from the speed flow relation, 92.76 is minus 0.0075 into Q. So where Q is the kind of your volumes, so then that need to be multiplied, so then you will get the 74.33. So Q is the volume of the traffic in pieces per hour in a year. which we have considered, 2448 is the kind of the maximum hourly 10% volume, 245. So this volume we have taken to estimate a time related congestion factor. So any questions till this point? Why we need to have the two different congestion factors? Why it is important to have time related congestion factor? Why we have the distance related congestion factor? Any thought process on that? If you ask some questions, then it will be interesting. Otherwise, it will be boring for you.
Sir, maybe there will be the concept of peak hour.
Okay, very good. So there is a peak hour concept. Okay. Apart from that, any other thought process on that?
Answer the number of lanes,
Yeah, okay,
maybe.
number of lanes. So let's try to understand the distance related congestion factor, how it is derived actually. So it is derived with respect to the volume by capacity ratios. But the time related congestion factor, it is derived with respect to the some kind of speed they have given. So corresponding to the maybe with respect to the speed flow relations. So based on the given corresponding to the given stretch of the point of time. So what is the variations of the speed? Let us assume this is the stretch of the speed I am taking. So then I find out that so there is a kind of the speeds are very high, maybe like the 100 kmph they are traveling. So most probably if you find out or if you estimate a speed of a vehicle of any category or any type or any point of the time of this section is traveling with respect to the 100 kmph. But at this point, if I'm looking that the speed is not actually that easy to maneuver of this kind of curve or maybe like any other kind of aspects related to the specific location of the environmental factors or maybe any other case, maybe gradient or maybe like the rise and fall or like the kind of roughness of the section of anything probably. So that means what we are expecting the speeds might be maybe varies respective to the section to section. At the same time, the volume by capacities, if I'm taking the capacity might be the volumes might be reaching to the very closer to the closer capacity at these blocker sections actually. So which means that when I'm taking a volumes corresponding to the densities or maybe like the number of vehicles I'm counting, so that might be reaching so very closer to the capacity side. So that's the reason. So it is not easy to understand to or maybe like the relevant or rely on the only one factor of the speed. Instead of that, so it is better to have corresponding to the different distances what is the kind of variations of your congestion factors. So it is also factoring of the different other kind of contributing factors on that. Even actually it is not only the rise and fall, it is not only the number of curves or like the junctions or maybe even if you have any kind of potholes that makes the change of the speed as well as the volume by capacity ratios will get changed. So that makes sense to understand that okay, there should be have the two different types of the factors related to the congestion that is relevant to the distance as well as the time related factors. The time is basically the given stretch of point of the time. What is the speed that the vehicles which are actually passing at that particular section. So then there is a higher and higher speeds expected. Of course, it is also depending on the surrounded by the total number of vehicles. That's the reason. So they derived with respect to the speed flow relations as the volume. So now what we are going to estimate here, the congestion factor we are going to drawn from the what factors we have seen, that is the intercept of the above equations respected to the average speeds of the vehicles like the cars. If I'm taking as a standard vehicle like passenger car unit, passenger car corresponding to the car. So then the whatever the speed you are getting 92.76 divided by 74.3 the average speed of the vehicle as car. So then I will get the congestion factor respective to uh, the different categories of the vehicles. So then what we have to do, the value of the congestion factor logically to be limited to the one if it is beyond the one actually. So and a maximum of the two. So that means now we need to find out whatever the factoring value we have according to the point 8. So again the question will comes, why we need to multiply again with the point 8 alone? So why can't it is point 0.9 like the any other numbers mostly? So mostly even if you look at the distance related congestion factor, so they are multiplied with respect to the point 0.8 after estimating the cumulative values respective to the distance related factor. So any thought process on that, why they are multiplying with the point 0.8 here? Or maybe generally we call as the correcting of the congestion factor with respect to the distance as well as time. So if you see, actually most of the time, if I'm taking a peak hours corresponding to our traffic volume, so for the 24 hours time, so it is expecting that there is 80% of the time the vehicles are occupied respective to the given stretch of the road. So mostly there is a kind of two peaks we may expect it easily. That is the congested case respective to if you are expecting that this volume, what we have, this volume is exceeding the capacity of the road, which means that most of the time, so there are two times only the volumes are exceeded, but the remaining two, like if I'm taking this block as the 2 hours, and the another block is the 2 hours, so the 4 hours, so 4 hour divided by 24 hours if I'm taking, so remaining almost here like the 20 hours, it is not expected as the completely blocked, or may like the highly congested case are reaching to the capacity case, but 80% of the time it is satisfying what we have designed it actually. So that's the reason. So we are multiplying a factor of the 0.8. So then if you multiply 1.248, what you have estimated as a congestion factor related to the time, 1.248 multiplied with respect to this 0.8, then you will get the 0.9. So in the case of the congestion factor, whenever the values are less than 1, it may be considered as 1. So corresponding to that, so what we have to do, so we have the volume by capacity, that is the speed under congested flow case, and the time related congestion factors case, both. So then these are the average speeds of the stretches corresponding to the different categories of the vehicles. Then we are trying to estimate as for each case of the 92.76 divided by 74.33. The same way 92.4676 divided by 57.066, like that we are doing for each and every categories of the vehicles. So then we are estimating that what is the congestion factors related to the time. So that's the way CFD we got, that is a congestion factor related to the distance. So somewhere we have the CFD we got, congestion factor related to the distance. So then we got the total CFD corresponding to the all the related to the your whatever the volumes we have taken corresponding to the volume by capacity ratios, that is the volume by capacity ratios corresponding to that. The same way we have that congestion factor related to the time, that is the CFT we also estimated. So then corresponding to that we estimated total congestion factor values. So this distance related and the time related vehicle operating costs are calculated using the economic cost of the data available from the table of these respective to the codal provisions of the SP30 of the 2009 of the NXLD. So then they have given that this is the total uh, vehicle operating cost, like the fuel cost, tire cost, and put together the total cost is the 1.46. So like if you add all cumulative values, then you may get the 1.46. So now what we are trying to do, so whatever the congestion factor we have, that factor we are multiplying with respect to your vehicle operating cost value, that is 1.46. So what we are trying to do now actually with that, okay, we got the 1.46. So what other cost we have, that is the value of the time. So that need to be taken again. So with that, so whatever the vehicle operating cost is there, we need to go through the each categories of the vehicles, what is the vehicle operating value of the time, that need to be again multiplied. So any questions or any points to be discussed specifically at this point? So we have seen the congestion factors estimations respective to the distance, respective to the time. Corresponding to the distance, volume by capacity we have estimated. Corresponding to the time, so we have estimated the by given equation we multiplied or we have taken respective to the flow. then we have estimated the speed, then the average speeds of the stretches of the different traffic conditions, then we have estimated a kind of projected values of the speeds, then corresponding to that we have estimated a time related congestion factor actually. So whatever the speeds we have here, so all these speeds are corresponding to the growth rate and corresponding to the simulated condition. So what is the expected speeds at the different case? Any questions? Okay. So now what we are doing, so the time related vehicle operating cost we are estimating. So this is the distance related time, because so there are two important aspects we have. So based on the distance, the consumption of the fuel increases, the tire, the degradation, like in terms of the wear and tear effect will increases, the engine oil, other oil, grease, and all the parts maintenance will be increases respective to the distance traveled by the vehicle. But if you look at the time related vehicle operating cost, so there is a fixed cost, then there is a depreciation, then the passenger cost will be included, and the commodity cost is included. So this passenger cost is corresponding to that what is the cost incurred by the passenger respective to the time, respective to their the value of the time and like that. So then the time related vehicle operating cost respective to the congested case they have taken. So then they whatever the 3.93 we have, that is multiplied with respect to the congestion factor value. So now what we are doing, so respective to the different categories of the vehicles, respective to the fuel, tire, or engine oil and all. So then this color is indicating respective to the distance related congestion factor, and this color is indicating with respect to the time related congestion factor. But there are different categories of the vehicles, may varies the fuel consumption, may varies the different types of the wear and tear effect of the tire, engine oil, everything will get varies. That's the reason for each category of the vehicles. So these components respective to the vehicle operating cost will varies, then corresponding to that it is estimated the same way. So the fixed and the depreciation, so then the passenger and commodity values also will get changes respective to the different categories. So then based on that, then they estimated the total distance related cost as well as the time related cost. So now what actually they have done, so they compared, they added these two values together. Now the total distance related and time related vehicle operating cost per kilometer estimated 1.46 plus 3.93, total 5.39. So then this is the case for the generally we are trying to look at for the car. The same way for the distance and the time related, if you are adding, so like we have the 21.4.73 plus the 17.26. If we add, then you will get for the bus like that. We have all the categories of the vehicles. Then we have to project it for the 2038 for all these cases. Then it is we'll get the total distance travel as well as the time related vehicle operating cost per kilometer. So now we know at the beginning of the discussion, we have seen that what is the total distance between these selected states. So that is the almost 72.56 or something. So that value to be multiplied with respect to this total vehicle operating cost. And apart from that, so we have the another important component, that is the wholesale price index value. So generally this value will be computed, what is the total amount of the gross value will be get changes respective to the different categories of the consumption, the demand side of the people or the public. So now if you see that, so there are different types of the components involved into the WPI value. So that is the linking factor between the 93 94 to the series. Then we have the WPI with respect to the other categories of the agriculture products and the manufacturing. But manufacturing is mostly highly contributed into the your WPI value. So it is the generally kind of the road use cost would increases with the accordance of the increasing of the vehicle operating cost. That may be impacting with respect to the total wholesale price index value actually. So that's the reason the wholesale price index value to be multiplied with respect to the total change of vehicle operating cost, because the vehicle operating cost may be also impacting respective to the different goods what we actually uh, like uh, uh, dispatching from the origin different origin to the different destinations generally. And this WPI is also varies respect to the different cases. So that may be respected to the weekly, monthly, the total amount of the goods transported will be different. So that's the reason. So the WPI may makes that there is a difference of the value as well as the difference in terms of the corresponding to the product case and corresponding to the time of the day as well as the monthly, the weekly, everything will get changes. And apart from that, it is also impacting that what is the total amount of the production and the consumption of the different regions. That is also makes the impact on your WP. So based on that, so what we are trying to do actually, so what are the vehicle operating cost we have earlier? So this is the 5.39 something for the different categories of the vehicles. So corresponding to that, so we are multiplying with respect to our WPI value. So now if you see that, so the VOC is multiplied with respect to the WPI. For example, if I'm looking for the car, 5.39 is multiplied with respect to the 1.429. So then you will get the 7.705. So this is the total vehicle operating cost estimated by corrected WPI value. I hope you got the point why we need to multiply the WPI, or any idea or any kind of points to be discussed in that. Hello, any questions?
Sir, can you please repeat that WPI means one more time? Yeah.
So basically, the WPI, that is the wholesale price index, will be released by the government of India in the monthly basis generally. So when they are releasing the data, so generally it is indicating that there are different commodities are included. That value is impacting based on the what is the total amount of the productions and the supply, and corresponding to that what is the kind of demands of these goods of the different categories. Mostly the manufacturing sector is the highly contributing into the WPA, because mostly the manufacturing industry having the lot of productions and the lot of consumption side, demand sides. Then there is a kind of incurred of the vehicles transporting of such goods from the one region to the other region. So what I'm trying to do, okay, if we have the more amount of the productions and more amount of the consumption corresponding to the different categories of the goods, so then what would be the operating cost respective to this increasing of the productions or maybe like the demand. So now if I'm considering, so then put together, because I don't want to look at each and every categories of the goods separately. So what I'm trying to look at, so I'm combiningly all the goods together. Of course, out of all the goods, the agricultural and manufacturing are highest contributor, but put together what is the total amount of the supply as well as the kind of the demand in terms of the vehicles respective to the transporting of the goods from one place to other place, and corresponding to that how the vehicle operating cost will get changes, specifically when I'm talking about the goods vehicles. And this factor is very very important. So that's the reason mostly when we are looking for the mobility respective to the highest categories of the roads, the goods vehicles are the highest contributor than the passenger vehicles in general. Does it make sense?
Yes, sir. But the good category will be varies, no, for vehicle to
Yeah,
vehicle. Means
even the goods category vehicles varies from the category, like type of the goods respective to the goods type, but the highest contributor is the your manufacturing system actually, or manufacturing sector together, put together as a manufacturing sector.
okay,
So 65 to 70 almost as the highest contributor in the WPA value.
okay, sir. Got it.
That's the reason. So then the vehicle operating cost they have multiplied with respect to the WPI. So then they corrected the vehicle operating cost respect to the WPI derived. So then these are the values for all the category of the vehicles. But if you see that there is no much impact respect to the two-wheeler actually, that's the reason. So it is not contributing anything in terms of the specifically for the WPI point of view, or even the vehicle operating cost actually. So it is very very less contributor. But other categories of the vehicles, specifically for the LCV, heavy commercial vehicles, and the multi-axle vehicles, highest contributors into the as the vehicle operating cost respective to the increasing or the multiplied with respect to the WPI values. So then we know the total stretch of the road. So that is the our 72.58 kilometers. So now if you multiply with that 72.58 with respect to each categories of the vehicle, So then if you get the value, so then 7.705 what we have multiplied with respect to the 72.58, then you will get the 559.227. So that is in terms of the vehicle operating cost for a total stretch in the year for the car in the rupees 559. So respective to that, each categories of the vehicle to be added. So now it is not enough actually, because if I'm looking for the value of the time when I'm traveling with respect to the car, and the value of the time respect to a specific good category or within the same passenger vehicles category, if I'm taking, so there is a different types of the value of the time can be observed or expected. So that's the reason the car, the value of the time is highest. So if you want to travel with the highest mobility with the higher speeds, then expected that the passengers will choose the mode as the car compared to any other categories of the vehicle. Then it is expecting that respective to the primary route, the value of the time is derived for the car is 62.5 rupees per hour. Like the same way for the two-wheeler is 32, then the ordinary bus is 39.5, and the deluxe bus passenger is 43.5. It is respective to the passenger vehicle category. The same way we have the other categories of the vehicles, even for the value of the time, but that is respective to the goods categories actually. What is the so sometimes there are different categories of the goods. There is a permissible good, then there is other categories of the goods, and these category of the goods will be kind maybe get changes their quality. So corresponding to that, we need to make sure that the choice of the mode to transport such kind of the goods will varies actually. So then we have the secondary routes, and we have the primary route, which including of the national highways and expressways, and we have the secondary route corresponding to the state highways and the MDRs. So then we have the different value of the times derived. So then this is the value of the time to be estimated corresponding to the travel time. So what we have derived earlier, 1.33 at the beginning. So then we have the value of the time multiplied with respect to the travel time of the each categories of the vehicle. So then respective to that, so we have the from the 2019 to 38 projected values, then we have to estimate the value of time in the rupees. Then what we are trying to do actually, so then we have the toll, base rate of the toll values. So that is the 0.65 and for the car, and the 2.2 for the bus, which is given as per the uh, standard values of the IRCSP 30. So if you take that values, then if you multiply with respect to the distance, then you will get that what is the toll fees for the stretch. So for the car, so that is the given stretch of the per kilometer length basis actually. So that is the 47.2. So the value for the car at the 2019. So if you see, so it is not varying respective to the increasing volumes, or maybe respective to the increasing of the year. So that may be the toll fees will be having the derived respective to the standard values, but it may varies respect to the some kind of the growth rate they will keep into the projected values of the base rate of the toll fees generally. So now we need to find out a generalized cost. First of all, what is meant by the generalized cost? So we have the value of the time, then we have the vehicle operating cost is different, then we have the tolls respective to the base, then put together. So we generally estimating a generalized cost value. So that means, so but very simple way if you want to understand it actually, so like you have transporting a good from the basic field, agriculture field, and to the nearest marketing centers. From that again it is transporting that with respect to the highest categories. So like the from the using of the expressways, or maybe like any other categories of the road. So this is the kind of the marketplace from the agricultural field. So then we have the centers like the maybe like the supermarket, something like that, or maybe like the disposal markets actually we call. So then what we are, so when you are transporting from your agriculture field to the nearest marketplace, the mode what we have used, so maybe like the tractors or something like that, it may be different. And the mode what we have used, so and the expressways maybe like the truck, something like that. And again, if you want to transport very local centers, that maybe mode is different, maybe like LCVs. So then each category of the modes having their own value of the times, as well as their own value vehicle operating cost. It is the vehicle operating cost from the the production side to the your consumption side is not same. So then there is a variation of the production side to the consumption side. The vehicle operating cost is varies respective to the different categories of the vehicles. The value of the time will be varies, and the tolls it may be like corresponding to the given stretch of the roads that might be fixed. So what you have the distance, then what you have the base toll that is fixed. So then if you put all together added, so then you will get the generalized value of the cost respective to of your public or like the goods which are transported from the origin to the destination point. Does it make sense? Are any questions on this? Any questions or any points to discuss?
No, sir.
Okay. So once you got this value, so then we have the generalized cost in a year. Then the same way what we have seen, it is the just for the year. So we need to multiply with respect to the total amount of the days which are accumulating values respective to the each categories of the traffic. So then we have the total value as the 689. So then that is multiplied with respect to 365 with respect to the total traffic is estimated. Then you will get the 6847.7. So this is the for the only car. The same way we have to multiply with respect to the all the categories of the vehicles respective to the projected entire 2038 case. So now with that, so you will get the total vehicle operating cost value. So when you are adding put together all the values, then you will get the total vehicle operating cost. So now based on this total vehicle operating cost, then we can identify that what is the total amount. It is like the worthwhile to suppose if you want to invest. So or like you have the total vehicle operating for the base case. So let us assume that you have the total vehicle operating cost of the stretch. So whatever you have seen as the base case scenario. So then this is the stretch of the road I'm taking. Let us assume between the Mumbai Pune of the stretch. So like I know the vehicle operating cost for the base case. So I'm talking about the base case and the vehicle operating cost for the improved case, or maybe like the development after developing or modifying of the stretch for the two-lane, four-lane divided roadway, strengthening of the road or widening of the road, something else. So then we know that what is the change of the vehicle operating cost respective to the change of the condition of your road. So then if this cost is actually as the benefit is higher than the cost as the financial cost is incurred into the project, so then if it is greater than one is indicating that this project is viable to implement. So this is the way generally it will be analyzed the economic evaluation of the project in general, any projects. So if you have any questions, we will discuss. Otherwise, this is the discussion about the estimations of the vehicle operating cost of a project. So let's see the other case study of the Madurai Kanyakumari. So now if you see that actually, so this is the kind of the route one. Then we have the, there is another route. There are three routes are there actually when you are traveling from the Madurai to Kanyakumari. So you are expected to pay, there is a 4 tolls are there. And when you're traveling corresponding to this route, you're expected to pay the 2 tolls. And when you're traveling for this route, it is expected to pay for the 2 tolls. So the general phenomena of the human nature, so we are always trying to like maybe omitting of the sum of the tolls by changing of the routes, whether we don't know what is the vehicle operating cost will be higher by changing of the routes, what we are expected to pay for the as the toll. So that need to be understood, need to be understand. So corresponding to that, so this analysis makes that what is the vehicle operating cost of the different stretch of the roads of the route 1, route 2, route 3. The same way, so first we need to have the idea of the vehicle operating cost respect to the distance based factors and the time related congestion factors like the fuel cost, tire and engine oil and something like, and the fixed depreciation and the other cost, passenger cost. Corresponding to that, we generally have the distance related vehicle operating cost is 1.51 and the time related congestion vehicle operating cost is the 1.33 and the total vehicle operating cost is the 2.84. So what actually this if you recall the actually what what we had discussed earlier, so it is all about there are two important factors are impacting. So that is, one is with respect to the what you call the curvature factor, as well as the raise and the fall. So generally we generally call as the bump values. So are my like what you call roughness indicator. Okay, so this is the roughness factor, meters in per kilometer. Generally the roughness is given for the 0, 5, 10, 15, 20, something like that. So out of which we have to interpolate for the given roughness factor of the 3 meters per kilometer, what is the values we have. So by the, if you look at the IRC SP30, so the roughness values are there. So then corresponding to the 3 meters per kilometer roughness value, we have estimated that by interpolation of the all the cost. Then we have also estimated the distance related and the time related factor. So then the total factor of the vehicle operation cost is estimated. Then the same way we have the average speeds and the distance traveled and the travel times, and corresponding to this is the given data. So the distance traveled from the 245 kilometer of this stretch actually. So this is the corresponding to the 245 kilometer stretch, and the average speeds of the stretch has given, and the travel times corresponding to the stretch of the different categories of the vehicles also given, and the value of the times of the different modes also given, 62.5, 32, 39.5, which are taken from the IRCSP 30. So then the toll rates corresponding to this is the actual toll rates corresponding to the different stretches of the tolls. Like this is the first toll values, the second, third, fourth, corresponding to the different categories of the vehicles. What are the toll rates that has given here actually? So there is no toll price for the two-wheeler. So then these are the toll rates corresponding to all the categories of the vehicles. So then the wholesale price index, so corresponding to that, what we are trying to do. So then we have the value of the times estimated corresponding to the adjusted WPI factor. So then we have the vehicle operation cost estimated corresponding to the WPI factor. So then the toll. So then the same way what we have done in the earlier, the generalized cost is estimated for the different categories of the vehicles. So then if you see that, so corresponding to the generalized cost of the different categories of the vehicles of the route 1, 2, 3. So the route 1 is the 245 kilometer, route 2, 264, route 3 is the 253. So then if you see that the generalized cost value, so the route 1 is the 1814. So then the route 3 is the 1550, and the route 2 is the 2133. So now you can understand that, so how this generalized cost can impact, even if you try to change the distance travel, or maybe like trying to avoiding of the congestion, it does not mean that what we are actually trying to pay which will be okay or not. So that is all about the economic evaluation of the project with the two case studies I have given. So if you have any questions, we will discuss, or else we'll, yeah, it is almost 4:20. If you have any questions,
Sir, one request to you. Can you please
yes,
share this slide with us?
I have already. Okay. I will share today evening. We are going to share the
Yes,
materials.
yes. Also, one request. The Vinayak sirs also. Vinayak sirs.
Yes, sure.
Yes. Thank you, sir.
Yeah, we'll share.
Yes.
I will request Professor Vinayak to share that Excel sheet. Once I got it, then I will share with everyone.
If possible, that sir PPT is also shared, or the last day they will share.
Yeah, we'll share the materials. We already made a kind of PDF of all
Okay.
these slides. Then we
Okay.
are going to share with that. If any slides are missing, then we'll post it accordingly.
Okay, sir. Got it. Thank you.
Any questions or any thought process or any points to be discussed according to the presentation, or maybe any other points are related to the morning to the evening sessions or afternoon session?
No, sir. It is good. No, sir.
Okay, if you don't have any questions, we'll stop here. So I am requesting everyone to join properly exactly at the time, 10 o'clock tomorrow morning. So then please be online. Okay, even if any net issues are there, please immediately you can join after discontinuing or disconnecting of the session, because it is mandatory to have the attendance to get the certificate actually, as per the rules or the policies of the GAN as well as the IIT Hyderabad. So this is our humble request to everyone. So if you don't have any questions, then we'll stop here. So I'm going to share very shortly the materials or the PDF what we have created. So tomorrow's session is going to start at 10 o'clock. The first session will be taken by Professor Vinayak Dikshit. Then the second session from my side, and again afternoon will proceed by Vinayak. So thank you all. So I'm closing the session. So sir, are you there? Yeah, we will share all the materials, no issue on that. And we will also share the feedback forms at the end of this maybe like workshop, maybe on Thursday, somewhere Thursday or like around Thursday, or maybe like the Friday morning session. Most probably Thursday third session. So we are going to share the feedback forms as well as the request respective to the what name to be given in the certificate, like that. So some of these details will be asked. So it is mandatory to fill the feedback forms, as well as there is a feedback form from the GAN, that is IIT Hyderabad side. That form has to be mandatory to fill, as well as the feedback from the NIT Warangal. And we are also going to share a feedback form as a hard copies. You have to fill and you have to make a signature on that, uh, or you need to fill as well as you need to send it to back by making some signatures, digital signature, like that, because we have to submit all these forms to the GAN office actually. So these are the some of the kind of information or the details from my end. So if you don't have any questions, we'll stop here. So thank you all. Thank you for joining. I hope you got some takeaways from these sessions of the morning to evening, like the 3 sessions. So if you are not able to understand any single point, you can stop us, or you can take a note on that and you can ask at any time till we have the 4 more days. Thank you. Thank you all.
Thank you, sir.
Thank you, sir.